Hey everybody, this is Ben and welcome back to another Leetcode video. And today we're going to be looking at problem 763 titled Partition Labels. So we'll read through the prompt, we'll talk about the pseudocode, we will walk through an example, and then we'll code up a solution. So you're given the string S, and you want to partition the string into as many parts as possible so that each letter appears in at most one part or partition. Note that the partition is done so that after concatenating all the parts in order, the resultant string should be S. Return a list of integers representing the size of these parts. Let's go ahead and talk about the problem a little more here. So we need to break the string into as many substrings as possible, where each letter appears at most in one substring only. We need to make sure that each partition, or substring, when concatenated together, equals the original given string. Finally, we need to return a list of the size of all partitions / substrings, kind of interchangeable there, that we have found. So what is the strategy here? We can iterate through each character in the given string. We need to take the first character we see and determine where its last appearance, its last index, is in the given string. We set the last appearance as our current endpoint. We then iterate up until this endpoint, and when we hit a different character than our first character, we check if this character's endpoint is greater than the original endpoint. If it is, we update our endpoint to the new, greater endpoint. If our current I, our current index, equals the endpoint, we know that we have found an optimized partition. We add the length of this partition to our list, and we continue iterating through each character of the given string, repeating the original process. So how can we store all the last indexes of each letter in the given string? We can simply do this through a hash map. We will also keep a previous integer variable to store the ending index of the last partition, and we'll initialize that to -1, not 0, updating at each endpoint. Now let's talk through the pseudocode here. So first we'll initialize a hash map. We'll initialize a list, and for each character in our given string, we'll put it in the hash map. So our current character and then our index I. So since we're going from least index to greatest index, this will automatically store the last index we have seen for each character. And then we end our for loop, initialize our integer prev to -1, initialize integer n to 0. Now we say for each character in the given string, end equals the max of end and map.get current character. So we're testing if our original endpoint versus the current character's endpoint, whatever is greater equals our new endpoint. Now if I equals n, we know that we have finished a partition, and we can add current index minus prev to our final list. And then we set prev to the current index, marking the end of the last valid partition. End our for loop, and return our list. So let's look at an example here. We'll take the string S, which is ABA, BC, BA, CA, DE, FE, GDE. We'll initialize a hash map, initialize our list. Now we'll say for in I equals 0, I less than s.length, I plus plus. Go ahead and put our current character with our current index into our map. Now end that for loop. So here's what our map looks like after that for loop runs. Last index of A is 8, B is 5, C is 7, so on and so forth. Note that these are the last index occurrences of each letter in the given string S. Now we'll initialize prev to -1, n to 0, and now we run kind of the meat of our algorithm here. So we have another for loop, again, in I equals 0, I less than s.length, pretty standard. Let's talk through each iteration. So we have, when I equals 0, current character is A. So just imagine s.character at I. I'm just doing that for you. It's going to be character A. Now we set end equal to map.max end and map.get current character. So this is going to be the max of 0 and 8, and obviously the max is 8, so we set end equal to 8. If I equals end, 0 does not equal 8, so that's obviously false. Now we move to our next iteration. I equals 1, character is B. Go ahead and test the endpoint. So we'll say max of 8 and 5, so this is our current end. This is the map.get B is 5. Obviously 8 is greater, end remains 8. We have no changes. Now we test our if statement here. 1 equals 8, that's false, and we move on. I equals 2, character is A. Go ahead and test this again. Now we're doing 8 versus 8, so n is just going to remain 8. And does 2 equal 8? That's false, so we move on. I equals 3, B is our character. Test 8 versus 5, n remains 8. 3 equals 8 is false, and we move on. I equals 4, we have C. Again, C is not going to be greater than our current endpoint. Remember, we're getting map.getC, so the last index of C is 7. 8 is not greater than 7, so n will just remain 8. And 4 equals 8 is false, so we move on. I equals 5, get B. Same process, max 8 and 5, n is going to remain 8. 5 equals 8, false, move on. And then same thing happens for iteration 6 and iteration 7. I'm not going to explain those. Now we'll jump to I equals 8. So our character is A, and our max is 8 versus 8, and n remains 8. So now we've hit a point where if I equals n, this is true. 8 does equal 8. So what we need to do is add our length of our current partition to our final list. So we find that through I minus prev. Notice we're at index 8. We initialized prev to -1 so that we could offset for length, because remember, an index is based on zeros and length is starting at 1. So there's obviously that one difference there. So 8 minus -1 equals 8 plus 1 equals 9. And we add 9, the length of our current partition, because index 8 would equal length of 9, to our final list. Then we'll set our prev variable equal to I, so prev now equals 8. Now, I equals 9, starting a new partition here. So this character D, we're going to find that its last occurrence is 14, which is greater than 8, so n now equals 14. Does 9 equal 14? Nope, and we move on. I equals 10, character is E. E's last occurrence is 15. This is greater than 14, so n now equals 15. 10 equals 15, false, move on. I equals 11, same process. I equals 12, same process. 13, same process. 14, same process. Not going to walk through those. Now when we hit I equals 15, character is E. And our max comparison here is 15 versus 15, so n remains 15. And what we'll do is we'll set I equals end. We'll test I equals end. And as you can see, 15 equals 15, that's true. So we need to add the length of this current partition to our final list. So we'll say l.add I minus prev. I minus prev equals 15 minus 8, which equals 7. Now our list looks like this. We have 9 and 7. Set prev equal to I, so prev now equals 15. And that is all the characters within our for loop, so we end our for loop. Then we return L, which is, as we just talked about, 9 and 7. This is the maximum amount of partitions with their corresponding lengths, so that each letter appears in at most one partition. So we have two different partitions, lengths of 9 and 7 respectively. So let's go ahead and code up a solution together. We'll start by making our hash map, and make sure you import the necessary libraries to do this. You can just use the asterisk wildcard if you'd like. So we'll say hash map character integer. I cannot type. Map equals new hash map, and we'll say list integer L equals new array list, and we'll say create our initial for loop to add all the values to our map. So we can find the last occurrence of each character in our given string. So that should do that. Then we'll say int prev equals -1, int end equals 0. For int I equals 0, I less than s.length. So our same for loop syntax again. We'll set end equal to math.max end and map.get s.character at I. If I equals end, I'll say l.add I minus c. C equals I. Or I have a tendency to just use very basic variable names. So we'll do prev. That looks correct. And then we'll just return L. So let's go ahead and run the program here. I forgot to add my index. There we go. As you can see, that works. We'll go ahead and submit it. It tends to run slower while streaming sometimes, but looks like this was pretty decent. My last submission got me to 5 milliseconds, which I think was maybe around 75% faster. Memory here a little more, so you can get this better as well. This is just my solution I came up with. Obviously, there's other ways to do it. If you found another way, feel free to share it. Thank you very much for watching. I hope you learned something in this problem, and have a great day.